Okay, today is about stretching and shrinking. It's part 2 of this. And so the hard kind of problem I want to go over is what if it's been stretched? You know it's a square root, but it's been stretched and you're trying to figure out, like, what's the equation for it? That's the kind that we got to be able to master by the end of the day today. All right. And I'm going to start by saying, okay, this is a square root. Do you get that a normal square root? It's always good to graph it right on the same axis. Do you get that the normal square root's there? Does it look like the blue one's been stretched? Okay, if you haven't gotten this part yet, yeah, it looks like it's been stretched. And does it look like it's vertically or horizontally stretched? I'm hoping you see vertically. And it's straight above the other points, but it's higher. All right, so now I'm going to undo those little changes there. I'm going to make one more point. Yeah, I'm off a little bit. I went up a little too high on this thing. I'm going to make it there. Okay, so there's some points on my graph, and I want to say what's the equation for this. Well, first of all, would you agree it's a square root of x? Would you agree it has not been flipped in any direction? Therefore, there's no negatives. Do you agree that it also was not moved to the right or left, and it was not moved up or down? Some people might feel like it's been moved up. It hasn't been moved up. If it had been moved up, this wouldn't still be at 0, 0. If it had been moved up, then that would have been at like 0, 1. All right, so it's not been moved up. The only thing that happened is a stretch. Now, is that a vertical stretch? Yes. And therefore, it's the number that goes right in front, right there. And then we'll keep it simple. We're not going to make it a vertical stretch of like 1.9. It's always going to be probably 2 or 3 or maybe even a 4 for your vertical stretch, because we can't make them that complicated. They're hard enough as it is. So would you take a shot at what you think the answer is? Y equals what? 2 root x. Now, what if your life depended on it? What if you had to know that that blue one, that's the one we're doing here. Maybe I should have written it in blue just to make it match the graph. What if I needed to know if that for sure was actually it? Because again, the graph would be given and you have to write the equation, and you're not sure this is right. You can always make an XY chart. It's your best friend in graphing. You can always tell stuff from that. Would you take the XY chart and see if the points that are on the blue equation actually work? As in this one, and this one, do they actually work? If this thing doesn't give you those points, if they don't work, then it's not the right equation. Test it. Here's 0, 0. 0, 0 isn't the greatest point to test because usually when you put in 0 on a parent function, they almost all go through the origin. So 0, 0 is usually going to work. And it did. It's good that it did work, but it doesn't really prove much. But how about this point? 1, 2. 1, 2. If I put that one in there, that will really tell me if I'm on the right track. So I'm going to put in a 1 here. Does it actually give me an answer of 2? So then 1, 2 worked, and that means it's the right equation. It would be incredibly unlucky to have tested 2 points that they both worked and then it was somehow wrong. But if I really, really, really wanted to be sure, I'm going to test a third one, and that's 4, 4. If I put in a 4, does it actually give me a total of 4? Yeah. 2 times the square root of 4 is 2 times 2, which is 4. So 4, 4 worked. I know that's right. Do you get that the blue one was stretched? And we figured out that it was a vertical stretch. And that number that I just circled right there was pretty much to keep it, these are hard enough as it is, that's probably either going to be a 2 or a 3 or maybe a 4. We're not going to make them weird stretches. This is hard enough. All right, let's make another one like that and see if you can do it. Let's say I had, this one's going to go backwards. So moving to the left is what I should say. Here's one without a stretch. Let's just make sure you can do this one. This one does not have a stretch. What's the equation for it? It does have a move, but not a stretch. I hope that feels pretty easy. Absolute value of x, and it's been moved which way? To the left. How far? 5. So how do I do left 5? Plus 5. Are there things that your life depends on that you might actually have to calculate? Yes. Let's say that you are going to go on a dive. And let's say you go down 80 feet and you screwed up on how much oxygen you're supposed to have to be able to get back up to the surface and use up all your oxygen getting down to the 80 feet. Now you're 80 feet down and you have no oxygen. You could die. Okay, so that's a big deal. So you got to be able to, there are times when your math could kill you. All right, so let's say that this was really important. What's your best friend to check these? XY chart. Yeah, check the XY chart. And let's make sure that a few of these points actually work. Like, let me be that one. -4, 1. If I actually check and does -4 when I put it in, does it actually yield a 1? Then I did it right. And if I really want to be sure, check a couple points. Okay? I'll check one more. -5 should go with 0. If I put in a -5, does it actually come out to 0? Yes, it does. So cool. I know it's right. All right. That's not that hard. That's not what was killing everybody last hour. It's what if this thing had been stretched? Then you have to write the equation for it. All right. Well, I'm going to graph right in the same spot. I'm going to graph one, and I'm going to see if you can figure out what kind of a stretch I am doing on it. If you figured out what I just did, give me the equation for the red one. Not the green one. We already had that equation. What's the equation for the red one? Okay. I'm hoping this wasn't that bad, but we'll see. Y equals absolute value of x, because that's what this graph is an absolute value graph. Okay. Then, do you agree that it's been still moved to the left and therefore plus 5? You with me so far? Okay, now, I did draw it in front of you, and I hope you saw what I was doing was making this higher. Each point was higher than the other point. Like this point right here, it went twice as far. Not twice as far, 3 times as far. Sorry about that. I went from 2 to 6. That's 3 times as far. And that was the key, is how many times farther is it? 2 compared to 6. That's times by 3. Therefore, there should be a 3 right there. Raise your hand if you had that one right. Okay, awesome. I cannot explain why I was only getting one person last hour to get those right. Or 2. All right, I must have been saying it in a confusing manner. All right, I'm going to give you another one. See if you can get this. Here's a square root. They look different. Okay, here's a square root that is going to be upside down. Here's normal square root that's upside down. Okay. And this is how this one looks. Whoa, been stretched a lot. y equals, and it's a square root, that much should be obvious. How much of a stretch or a shrink or whatever it was, how much was it? Now, my advice to you is, remember last time I had the two graphs like right side by side? I recommend that you actually go and put this parent graph right here and say, this is, oh, well, naughty. There we go. And then go there. And then go that's where the parent graph would be if it was just a flipped one. And if you have these side by side, maybe you'll be able to tell how much of a stretch it was. And this is too hard for a regular class. But wait, you're in honors. It's not too hard for you. Okay. Just do one little thing at a time. Does it look to you like it got moved? Okay. Which way did it get moved? Left, right, up, or down? Left. Left, how far? Left 6. From the original, which would look like that, it got moved left 6. Do you guys agree and therefore put a plus 6 on the inside? Raise your hand if you had that right. Okay, good. Next, would you agree it's been flipped? Is it a vertical flip? It was an up-down. Yep, it was a flip like this. See? It's a vertical flip. And if it's vertical, it must be a VO. Vertical on the outside should be a negative on the outside. How many of you had that as part of your answer? Okay, good. Next. And the last thing is the stretch. Usually, I think we do more vertical than we do horizontal. Does this line up vertically with that? Then that was a vertical stretch. So that means it's a number that's going to go right here with this negative. It's going to be like negative something. Do you think we'll have negative 4.8? Is that pretty likely? No, it's probably negative 2 or 3 or 4 or something like that. Say it if you know it. 4 is correct. That's a negative 4. Now, let's say I heard somebody say, I thought it was 3. And here's how you could be sure. Because again, if your life depends on it, or in this case, your grade depends on it, you really want to check with the XY chart. How can I know this equation's right? Because if I stick in the points that are on it, here and here and here, they better work. Know what I mean? And if I actually stick the points in it, I'll know if it works. So I'm going to pick this one. If I stick in a negative 6, it better work. Well, let's try it. Negative 6 goes in, and it makes 0. It's just 0. Negative 6, 0 is on my graph. That's a good start. But that doesn't have any stretch on it yet. So that could have worked, and I still could have been right, even if it was the wrong equation. So I'm going to try another one. This one. That is the point. Negative 5, negative 4. Does that one work? Well, if I put in negative 5, let's see. Negative 5. When I add the 6, I get 1. Square root of 1 is 1. Multiply it by negative 4 makes negative 4. Yay, it worked. So I did it right. If 2 points work, then I'd say I'd feel confident that you can trust it. You don't have to go through and do every single point. Okay, if you got a couple points working, then you must be right. Okay, Now that's at the end of the assignment. That is the toughest stuff. So that means the rest of it must not be that bad if the most of you guys are getting it. So I'm going to go and find the assignment. You should too. I'm going to pause for a second while we find it. Okay, so the assignment's Honors Higher Algebra, Stretches and Shrinks B. Okay. Now, this first one is kind of a more normal question. It's just describe the transformations, then graph it. All right, so let's do A here together. Describe what happened. That right away they start with something weird. I'm supposed to start on the inside. That's a divided by 2 on the inside. Well, first of all, Mr. Server taught me that that's horizontal on the inside, and therefore that's a horizontal thing. It's a horizontal, well, how about this? What if your smart kid next to you leans in and says, hey, that's the same as this? I'll be your smart friend today. Good. Does that help you see that it was a horizontal what? It seems like it should be half as wide, which would be a shrink. So it's actually twice as wide, so it's a stretch. It's always opposite world in there. If it's a half on the inside, that means it's actually going to be twice as wide. No. When it was divided by 2 here, that wasn't flipping it. I was just putting it out in the front. 1/2 x is the exact same thing as x over 2. X over 2, 1/2 x, exact same thing. That's not flipping it. Okay, so the 1/2 x now is it's just about interpreting what does that 1/2 x mean. Well, 1/2 on the inside, it seems like it should be making it half as wide, so it's not making it half as wide. It's making it twice as wide. Horizontal stretch factor 2. It is going to make it twice as wide. I know. The stuff on the inside is the first thing that often gets people is, what do you mean? It seems like it should be half as big. No. It's because it's on the inside. It's not, you can't trust it. It's dying to you. It's going to be twice as big. Okay, now I'm going to move to the outside, and that's this, and that's simple. It's up, 2. There we go. It's the only 2 changes. Twice as wide and up 2. Well, here's my normal x to the 3rd graph. I'm definitely off. That's just a sketch. Okay, but do you get that it's kind of the snaky looking thing? All right. Now, if I want to make it twice as wide and up 2, would you agree it's going to be kind of wider than normal and then up 2? Should be something like that green one. I know it's not perfect, but I tried to make it wider than normal and moved up 2. That's a sketch, though, and this is a graph question. Like, you'll have to actually have points on it, right? That's where the XY chart comes in. You've got to have an XY chart. And on your XY chart, you will lock in, like, for sure, exactly where this graph is. So then you take a point and stick it in. Do I just want to stick in, like, 3? No, that's ugly. Pick something that works nice. What could I put in for X that would work really nice? A 4 would work really nice. Why would a 4 work really nice? Because you can cut it in half easy, right? So 1/2 of the 4 would give me 2, and 2 cubed is 8, and then 8 plus 2 is 10. 4 comma 10 is on my graph. Over 4 and up, well, ooh, it's just off the graph. I would have actually counted that as a point, because it's only off the graph by 1. We could count that as one of your 5 points. You know how you're supposed to have 5? All right. That's one of my 5. We'll pick something else. Do you get if I go any bigger than 4, it's going to go way off the graph? So I'm backing off, and I'm going to use like 3. That's icky. Half of 3 isn't nice. So just don't use it. There we go to 2. Is half of 2 easy? Yeah, half of 2 is easy. Half of 2 is 1. 1 cubed is 1. 1 plus 2 is 3. So 2 gave me 3. Over 2, up 3. That's pretty close. My green sketch was, wasn't perfect, but it was pretty close. Let's do another one. Maybe put in 1. Half of 1, that's a half. That's kind of icky. I could do it. 1/2 cubed is 1/8. Then it's going to be plus 2 is 2 and 1/8. Ick. I don't want to do that one. So I'm going to stick a 0 in instead. So 1/2 of 0 is 0, and 0 cubed is 0 plus 2 is 2. 0, comma 2. I was right on that one. Got 3 of my points. Do you get how they're lining up with right where I thought the sketch was? So that's a good thing. That's what should happen. And I'm going to put in 2 more just to show you how 5 points would look. If I put in -1, that's going to be a fraction again. I'm going to put in -2. If I put in 1/2 of -2, that's -1. -1 cubed is -1. -1 plus 2 is 1. -2, comma 1. -2. Ooh, I was off on that one. Should be, what's going on here? 0, 2. Something went wrong. Oh, I was having trouble reading my graph. Okay, sorry. This little point right there should be over there. And I was actually closer than I thought on that one. I had just graphed the point wrong, sorry. Okay, now I'm good again. I just did put one of my dots in the wrong spot. All right, now I'm going to put in one more thing. I think -4 would work pretty good because I can take half of it easy, right? So I'm going to put in -4 right there. And 1/2 of -4 is -2. -2 cubed is -2 times -2 times -2 makes -8. Plus 2 is -6. So -4, -1, 2, 3, 4, and -6, 1, 2, 3. Yeah, I was way off on that one. So there's my final answer. It's not, my green one wasn't tragic, but it was definitely off. And once I got those dots, I can be sure I'm right. All right, now, these take a long time, so I'm going to cut your assignment down. You may skip E and F in this top section. E as in elephant and F as in Frank in this top section. And you can skip E and F in the next section. Next section is a lot easier, though. They're just like write the equation for them. But we're going to skip E and F here. And then in this last section, these two are important. You should know how to do that. But let's go to this last section. This one's brutal. I'm going to have you skip that one. I don't think we do anything that hard to you. But I think you need the rest of them. Like, I don't want to have you skip ones that are some of the most challenging ones in the test. You probably should practice those. The 3 at the end there are good to try. All right, before we still have like 13 minutes here, maybe 14. So before I turn you loose, I'd like you to do this one with me right here. Try to write that equation for this parabola, and hint, if I were you, I'd graph the parent parabola right here to be able to try to figure out what happened to the parabola. This spot right here changing to this spot right here, that's the key. Every parent function goes over 1 and up 1. I don't know if have you even noticed that? Every parent function goes through the point 1, 1. All of them. Except the circle. And circle's kind of different because it's not technically a function. After you move them, they don't. I mean, you can move something so it won't touch it. But my point is that you go over one and you go up one, and there should be a dot there. And you're right, there isn't one there. So therefore, it must be stretched. That's how you can tell if it's been stretched. See, like this one. Do you get how it's supposed to go from here? It's supposed to go over one and up one? And is there actually a dot there? No. So you know it's been stretched because there should be a dot there. Just check over one and up one and see. Supposed to be a dot right there. Which way did the dot get moved? All right, so on this one, I'm going to narrow it down to just the points that I said were important. Do you get that it should be over one and up one? And in fact, it's over one and up 3. Therefore, it was a vertical stretch factor, what? 3. Now, if I thought that that was the right answer, which I know there's something wrong with it, but if I thought that was it, do you get I could check out that XY chart and just make sure it's right? And it's not right. Because this one's also been moved. Where has it been moved? Up 1. So that's a +1 here. How else did the parent function, compared to where it normally would be, which is right here, how else did it get moved? To the right 2. Yes. So in there, put a -2. That's pretty complicated. But that's the right answer. If my life depended on it, I could check it by checking this point, 3, 4. Shouldn't 3, 4 work? Well, let's check and see if it does. If we put in a 3, do you get I get 3 minus 2 is 1. 1 squared is 1. 1 times 3 is 3. And then the 3 plus the 1 makes 4. Cool. It actually worked. I know it worked because I checked it. I took the point and I stuck it in the equation. All right. I know those are tough. Those are the toughest ones. Talked you through that one. This one. Sometimes it's easiest to just figure it out as if there wasn't a stretch going on. I know there's a stretch going on, but act like it was just here, like it wasn't stretched. And then figure out the equation, and then just add the stretch in at the end. All right. We have time to practice that still. This is always a challenge for kids. There's some kids that get it right away, don't get me wrong. So, I know there's like 7 of you in here that can just, yeah, it's no big deal. I just see, look at where the dot should be. Look at where the dot is. And they just go, there should be a dot right there, and it's over there. So it's horizontal, no big deal. But I know for some of you, this is hard. Use the XY chart to check yourself. Make sure you don't wreck yourself on the test. I think I'm quoting Ice-T there in a rap song.